Ever wondered what it takes to suspend over 800,000 tons of steel and concrete above a raging ocean current and the most dangerous waters of the Pacific? The Golden Gate Bridge, a marvel of engineering and design so audacious, it's left engineers scratching their heads for nearly a century. In the early 20th century, the idea of building a bridge across the Golden Gate Strait was dismissed by many as sheer madness. The strait, often cloaked in dense fog, was notorious for its fierce winds and deadly currents. No engineer in their right mind would dare attempt it, they said. But Joseph Strauss, a visionary with a passion for the impossible, saw potential where others saw peril. Strauss wasn't just any engineer. He was a man driven by ambition, creativity, and a stubborn refusal to accept no as an answer. His initial design was a combo of cantilever and suspension, a radical idea that raised eyebrows and doubts alike. But Strauss was undeterred. He famously said, "The bridge which couldn't be built, can be built." While Strauss led the charge, the final design of the bridge was a collaborative masterpiece. He enlisted the help of Charles Alton Ellis, a mathematical genius, and Leon Moisseiff, a suspension bridge expert, to refine his ideas. What emerged was an elegant suspension bridge, supported by two massive towers and suspended by cables nearly a meter in diameter. It was both practical and artistic, a balance of form and function. The main span of the bridge stretches 4,200 feet, the longest in the world at the time, and each cable is made of 27,572 individual wires, totaling over 80,000 miles if laid end to end. That's enough to circle the Earth 3 times. Standing at 746 feet, the twin towers of the Golden Gate Bridge were the tallest structures outside of New York when they were built. These towers are the backbone of the entire bridge, made from over 600,000 rivets each. They were designed to withstand the immense forces of the Pacific Ocean. But it wasn't just the height that made these towers remarkable. It was their foundations. Engineers had to dig deep into the bedrock, underwater, to anchor these colossal structures. Divers faced freezing temperatures and treacherous conditions, all to ensure the bridge would stand the test of time. An interesting fact, those rivets were heated until they were red hot, then hammered into place by workers with a speed and precision that would make modern-day construction crews envious. With the towering giants firmly anchored in place, the next challenge was equally daunting: how to suspend the bridge's immense weight over the treacherous waters below. This is where the suspension engineering came into play, and it all started with the cables. Spanning over 7,000 feet and weighing 24,500 tons, these cables were spun right on site, using a process called aerial spinning. Workers suspended hundreds of feet above the water, balancing on narrow catwalks, spinning wire after wire to form the massive cables. The technique required a level of precision that boggles the mind. Each of the 27,572 wires had to be perfectly aligned and tensioned to ensure the bridge could bear the weight of thousands of vehicles every day. The bridge deck, where cars and pedestrians travel daily, was constructed from thousands of prefabricated steel sections and assembled like a giant jigsaw puzzle, making it strong enough to support traffic while light enough to stay suspended between the towers. But the deck isn't just about strength, it's about flexibility. Engineers had to account for the fact that the bridge would sway, expand, and contract with the wind, temperature, and weight of traffic. So, they designed it to move, just enough to absorb the stress, but not so much that it would compromise safety. Let's talk about the color now. You might think the Golden Gate Bridge's distinctive, international orange paint was chosen purely for aesthetics. But in reality, it's a crucial element of the bridge's design. The color was selected because it stands out against the often foggy backdrop of the Bay Area, making the bridge visible to ships navigating the treacherous waters below. And maintaining this hue requires constant maintenance to prevent rust and corrosion caused by salt, wind, and fog. The bridge is repainted annually with 10,000 gallons of paint, a small price to preserve this world-renowned structure. Ever since the bridge was opened, over 10 million square feet of steel have been painted. Construction of the Golden Gate Bridge wasn't just a challenge. It was a dangerous endeavor. In fact, many thought it would be impossible to complete without significant loss of life. But Strauss, ever the visionary, wasn't about to let that happen. He insisted on installing a safety net, a revolutionary idea at the time. This net, which stretched beneath the bridge, saved the lives of 19 workers who fell during construction. They became known as the Halfway to Hell Club, a testament to Strauss's commitment to safety in an era when such measures were often overlooked. But despite the best efforts, tragedy did strike. On February 17, 1937, just months before the bridge was completed, a scaffold carrying 10 men fell through the net, killing them. It's a sobering reminder that behind every great engineering feat are the men and women who risked everything to bring it to life. From the relentless ocean waves to the infamous Bay Area earthquakes, this bridge has faced it all. During the 1989 Loma Prieta earthquake, the bridge shook violently but remained standing. The secret lies in its flexibility. The towers and suspension cables are designed to move with seismic forces, absorbing the shock and preventing catastrophic failure. This dynamic design allows the bridge to flex, stretch, and bend, but not break. And when the winds pick up, the bridge can sway up to 27 feet. That's the crazy engineering behind the Golden Gate Bridge. Remember, this isn't just a feat of engineering. It's a testament to what humans can achieve when we refuse to take impossible for an answer. If you enjoyed the video, don't forget to like, subscribe, and hit the bell icon.